In this video, we are going to talk about ions. Ion is any species that is electrically charged. It is formed when an atom loses or gains electrons. Loss of electrons results in positive ions. Gain of electrons results in negative ions. Negative ions are also called anions. Positive ions are also called cations. An example over here is for formation of chloride ions from chlorine atoms. When chlorine gas, which is in diatomic form, gains two electrons, it forms two chloride ions. Sodium metal, it loses electrons and forms sodium positive ions. Group 1, group 2, and group 3 elements. Group 1, 2, 3. They generally lose electrons and form cations. All the metals actually they form cations, and the metals belonging to these three groups they generally form cations. And group 5, 6, 7 elements, meaning those which are on top, they form negative ions called anions. But there are exceptions to these elements as well. For example, the lead 2 plus, which also belongs to one of these groups, forms positive ions as well. So there are exceptions over here, but over here, group 1, group 2, and group 3, they always form cations. Okay, so now let's move forward. What's the difference between an atom and an ion? So the only thing that differs between them is a subatomic particle, and that subatomic particle is the electrons, the number of electrons. The atom and ion of the same element has the same protons and neutrons, same number of protons and neutrons, but they differ only in the number of electrons. As sodium atom, when loses an electron, it forms sodium ions. So sodium atom, which had initially 11 electrons, because atom is electrically neutral, the number of protons is also equal to the number of electrons. Sodium ion that is formed has 10 electrons because one electron has been lost in its formation. The proton number doesn't change, so the protons have become one greater as compared to the total electrons which are there. So the net charge becomes plus 1 over the entire atom, resulting in the formation of a positive ion. The neutrons also remain the same, and the neutrons have no role in the charge because they are electrically neutral. Okay, now let's look at the type of questions that are asked in the past year papers. Oh, wait, let's look at another example of a negative ion formation, chlorine and chloride. Chlorine atom, negative ion, let's compare the negative ion with its atom, chlorine atom and chloride ion. The chlorine atom has a nucleon number of 35. Chloride ion also has a nucleon number of 35. Proton number is 17. Proton number is also 17 in the ion. So the number of electrons over here in the electrically neutral species is also equal to the number of protons, that is the number of electrons, which are also 17. Protons are 17. But over here in the negatively charged ion, the number of electrons are greater than the number of protons. That's why the overall charge is negative. Protons are 17, electrons are one greater, which means the electrons are 18, one greater than those of the atom, than those of in the than the electrons in the atomic form. So one more electrons results in a net negative charge. Okay, so the basically let's look at some of the exam stuff that is repeatedly asked in the past year papers. Okay, so I've seen MCQs in which you're given certain ions and then you're asked to arrange them in either the increasing proton number or increasing number of electrons or increasing mass number. So over here in our example, I've given sodium ion, chloride ion, hydrogen ion, and iron 2 plus. Okay, so the first point says that arrange them in increasing proton number. So proton number, let's first figure out the protons in each species. Well, it's quite easy. Protons are written in the subscripts. Hydrogen has 1 proton, sodium has 11, chloride has 17, and iron 2 plus has 26 protons. So hydrogen comes first, then followed by sodium, then chloride, and iron 2 plus. The second point says that arrange them in increasing electron number, number of electrons. So let's decide which one has the greatest and which one has the least electrons. Hydrogen positive has no electrons because the hydrogen atom H H1 basically, which had a proton number and an electron number of 1 and 1, had no neutrons and 1 proton and 1 electron. So 1 electron, the only electron that it had, it loses that electron and forms H positive ion. So 0 electrons, so it comes first. Then sodium positive has 10 electrons because 11 electrons initially plus 1 charge means minus 1 and 10 electrons, so sodium comes second. Chloride, a negative 1 charge means a gain in electrons, so 17 plus 1 becomes 18, chloride ion. And iron 2 plus means 2 plus, again plus means loss of electrons, so loss of electrons would mean that 26 minus 2 becomes 24. Okay, then the third one says arrange them in order of increasing mass number. That's also easy. Just look at their masses. The hydrogen positive has a mass of 1, so it comes first. Then sodium has a mass of 23, then it comes next. Then chloride, and finally iron 2 plus. Isotopes. Let's define isotopes. This definition is very important. It comes for at least 2 marks, and I've seen it several times being asked in the past year papers, so must learn it, okay? And these are some three points that cover the entire definition. Okay, so isotopes are basically atoms of the same element. Okay, this is important. They cannot be of different elements. So when they are atoms of the same element, this means that their proton number is gonna be the same, because whenever the proton number changes, the atom changes, the element changes, and the only thing that they differ in is the number of neutrons. The number of protons are the same, the number of electrons are the same, the number of neutrons are different, and due to the different neutron number, the nucleon number also changes. The nucleon number is also different. A nucleon, or also called the mass number, also changes. Okay, so they have different nucleon number or different mass number. Now I've given an example over here. Chlorine has two isotopes, chlorine 35 and chlorine 37. Chlorine 35 has a nucleon number of 35. Chlorine 37 has a nucleon number of 37. But they have the same protons, 17 and 17. Neutrons over here are 35 minus 17, 18, whereas the neutrons over here are 37 minus 17, which is 20. So 18 and 20. Similarly, carbon also has three isotopes, 12, 13, 14. These numbers represent its atomic mass, okay, or its mass number or its nucleon number. Carbon 12 has 6 protons. Carbon 13, sorry, it's not 6. Yeah, proton number is 6. Carbon 13 has the same number of protons, which is 6. Carbon 14 also has the same number of protons, which is 6. But the number of neutrons in carbon 12 is 6. In carbon 13, it increases by 1, which is 7. And in carbon 14, the number of neutrons are 8. Similarly, hydrogen has three isotopes: protium, deuterium, and tritium. Protium has no neutrons, so 0 neutrons. It has 1 proton and one nucleon. Its atomic mass is 1. Proton number remains the same, so 1, 1, 1. The number of neutrons changes, so 0 neutrons, 1 neutron, 2 minus 1 is 1, and 2 neutrons, 3 minus 1 is 2. So nucleon number and the neutrons are different, but the proton number and the number of electrons are the same because they are atoms, and the number of protons and electrons are going to be the same. This isotope over here, the tritium, is radioactive. Okay, thank you.